Welcome everyone. Thank you for joining us for today's webinar. My name is Monisha and I am the Senior Consultant at Alkamal Training. I hope everyone recognizes Alkamal Training since we are in the market for the past 10 plus years and we are the leading certification preparation center in Oman. We are dealing with the courses like PMP, CAPM, Six Sigma, RMP Primavera, etc. And today we are presenting the webinar on an overview on Six Sigma, which is presented by Ms. Durga. She has done MBA, PMP, and Certified Six Sigma Black Belt. If you have any queries during the presentation, please type them in the chat box, or you can unmute your audio and then ask. At the end of the session also, we'll be having a question answer session. Also, during the session, kindly mute your audio as well as off your video for better quality. So without any further delay, we'll turn the time over to Ms. Durga. Thank you.
Thank you, Ms. Monisha. Very good evening, everybody. I hope all of you can see the presentation, the screen. So I am Durga. As Monisha was introducing, I have done my PMP professional certification. I'm a certified green belt and black belt from IASSC. I'm into training and consulting for the past 12 years, and I've trained, consulted various government and private organizations in India, Oman, and UAE. So I have conducted so far nearly 150 plus training programs in project management, quality management, process improvement, root cause analysis, etc. So this is a brief about me. So today, the next 1 hour, we are going to look at an overview of what is Six Sigma and what is Lean. Because today people, when they talk about Six Sigma, they do not just talk about Six Sigma as a singular view. They talk about both Six Sigma and Lean together. So in fact, Six Sigma have, individually, it can be implemented. There is no problem about it. But nowadays, people come up with an integrated model of combining the Lean methodologies with the Six Sigma methodologies. So we are going to see a picture of, an overview of what is Lean, how is it different from Six Sigma, and how you can integrate it together to have a holistic improvement in your organization. So the agenda for today is we'll start with Six Sigma. What is Six Sigma? The origin of Six Sigma, and the step, the model or the steps to achieve Six Sigma quality in your organization. And then we will move on to Lean, origin of Lean. What is Lean principles? And then we will do a comparison between Lean and Six Sigma. And finally, I will give you an introduction, or I would say, I would give you an overview of what is this Six Sigma, green belt, yellow belt, black belt. You have heard about this. So we will talk about what are these and how to achieve your first level of belt. Okay, I'll give you an overview of Six Sigma green belt particularly. Okay, so that's the agenda for today. We have a lot more to discuss, so I'll try to complete it in the schedule as much as possible. So first, let us start with Six Sigma. What is Six Sigma? First of all, what is Sigma? Sigma is a Greek letter that stands for standard deviation. Okay, So Six Sigma is basically a statistical method, or I would say Six Sigma improvement involves a statistical tools, statistical techniques, and it helps you to understand the problem with the numbers. Okay, so you will collect the data from your processes, whatsoever process you do. You may be into healthcare, or you might be into call centers or BPOs or IT, whatsoever process you're into, your banking. So you will collect data about the processes which you want to improve, and you will analyze the data using statistical techniques. You will interpret the technique. Kindly mute your mics, please. You will interpret the technique, you'll interpret the data, and then you will arrive at the meaning, the real meaning of what is the problem is all about, the causes of the problem. And then you would implement the solution. And once you implement the solution, you would test, you would do a pilot test, and you would ensure your newer recommendation produces results. If it produces results, then you will go ahead and standardize that new recommendations. So that's Six Sigma, in a very nutshell. Okay. So before we get into what is Six Sigma, let us see a little history about Six Sigma. The major organization that have contributed to Six Sigma are Motorola and General Electrics. So usually people call Mr. Bill Smith, who was actually an engineer in Motorola. He was known as the father of Six Sigma. Okay, so you can see on the right side of the photograph of the Bill Smith, who was working as a engineer during 1980s in Motorola. So Motorola is known as the pioneer or the originator of the concept called a Six Sigma. But they have developed the Six Sigma, I would say. But the concept called as Sigma, the concept called as using statistical tools in quality, it has its history way back. During World War I and World War II, particularly during World War II, a lot of innovation was happening in the field, in all field, be it engineering, manufacturing, management, whatsoever. Take any field, there was a lot of improvements happening because resources are of very prime importance. Many countries, particularly the Western world, is into war. So whoever have got huge number of weapons, whoever have got a huge amount of resources, and whoever have the capability of using the resources in an efficient way, they win the war, right? So at those time, many management researchers, quality management researchers, contributors, engineers, they all came together, or independently, they were working on efficient or efficiency models, process improvement models, how to put resources in a better use such that you can manufacture at a huge quantities without wasting resources, such that you can have great amount of equipments and outputs in a quicker time, such that you have a great leverage in winning the war. So at those times, there was one man, there were actually two men. The first man, Walter Shewhart, who is known as father of statistical process control, or father of statistical quality control, SPC or SQC, statistical process control or statistical quality control. So he was known as father of SPC or SQC because he is the man who is known to put the statistical measures to understand and to control the processes and to bring quality, to bring great output, high output, quality and quantity, high productivity. Okay, so he is the man who is first known to put these statistical measures into picture, into the process metrics, and came up with improvement models. Okay, so Walter Schuhart is actually the real pioneer of Six Sigma, whereas Bill Smith, he used the concept of SPC or SQC, and he arrived at a number called as Six Sigma. I will tell you what is the meaning for Six Sigma later. I cannot give you the exact meaning, but I will give you, because it requires a lot of calculations for me to explain why is it called a Six Sigma. But I'll give you a picture about what is Six Sigma. Okay, what does this number 6 means? Okay, so he have come up with this concept called this Six Sigma. Okay, so he derived the concepts out of Walter Schuhart's SPC or SQC, and he came up with an improved model, right? And then General Electric's Jack Welch. If you have you heard of Jack Welch? Jack Welch is one of the popular CEOs of his times. He's one of the most popular CEO in General Electrics. So he's a very aggressive person when it comes to improvement. So he have took Six Sigma from Motorola, benchmarked Six Sigma from Motorola, and he deployed a Six Sigma across General Electrics. Even today, General Electrics is one of the known organizations to implement Six Sigma vertically, horizontally, 360 degree. So the Six Sigma have given a great result, successful results for General Electrics. Then slowly this model became popular. Honeywell took it. Many manufacturing organizations took it. And now, although the origin is from manufacturing, now it is most used in service industries such as IT, ITES, healthcare, education industry. So service, because most of the service industries are more into processes, they're more into operations. When it comes to call center or banking or hotel industry, or most of the service industries, they are into operations. So it has become a popular, not only popular, it has doubled, exponentially grown in service industries. Now service industries have devised or added or contributed on the development of Six Sigma model. So before we get into the meaning of Six Sigma, we need to understand what is the difference between precision and accuracy. These two terms are usually misconceived. People generally mistake that they are same. So when people say accurate, they actually think precise. Sometimes they use the word precise to mean accuracy. So there is the difference between precision and accuracy. We have to understand this before we move on to the next concept. So what is precision and what is accuracy? How they are different from each other? So precision means, the word precision means measure of exactness. Again, the word exactness is usually mistaken. Okay, people when they say exact, they actually think to target. Okay, exact is here. Exact does not mean to target. Okay, I will tell you what is exactness. So definition wise, precision means a measure of exactness, whereas accuracy means a measure of correctness. In other words, precision is a measure of reliability, whereas accuracy means a measure of validity. Okay, so what is precision actually? Of course, even though when you see the definition, it is pretty difficult to interpret the definition without an example. For example, let's say precision is consistency. I see somebody's mic is on. Kindly mute your mic, please. Thank you. So precision means stability, consistency. Whereas accuracy means trying to be on target, trying to be on target. Okay. For example, let us say a student. A student is, consistently he is taking 60 or around 60 marks in mathematics. So let's say in one of the examinations, he got 60. In another examination, he got 62. In another examination, he got 59. In another examination, he got 58. In another examination, he got 60. So his mark is like 60, 58, 59, 62. So around 60, closer to 60. You understand? So this person is consistent. This person is stable. Next time when he's writing the examination, can you predict his score? You can very well predict his score because he is taking somewhere between around 60, right? So next time also you can say he will take some score nearer to 60, maybe 58, 59 or 60, 61. So around 60, not you can say that this particular man is predictable. A student is predictable. So being predictable, being stable is what we call as precision. Okay. But what is accuracy? Accuracy is, let's say you have a target. So let's say the target for you, for your student is 80 marks. Okay. So the person who have got 60, 59, 58, around 60, although he is precise, he is not to the target. He is not even nearer to the target. So this person who have got 58, 59, 60, 61, 62, this guy, he is stable, he is precise, he is exactly repeating what he is getting. He repeats what he gets every time, but not to the target. He is not accurate. He has to be improved to become accurate. All right. Whereas, let's say another student, and this student, let's say in one of the examination, he scored 65. Another examination, he scored 85. In another examination, he scored 78. In another examination, he scored 41. In another examination, he scored 86. Now, this person is unpredictable because he's sometimes he's reaching 70, sometimes he's reaching 80, sometimes he's reaching 90, sometimes he's reaching 60, 40. You can see a great variation. He's not predictable. Next time when he goes for the examination, you cannot predict what he will get. All right. So this guy, although he has hit the target twice, I told you one time he got 80, another time he got 86. He hit the target twice, but he is not predictable. He is accurate twice, but not predictable at all, but not precise at all. All right. So let me show you another picture. Look at this picture. Let's say you have 4 persons who are into shooting the bullseye. Okay, so you have 4 bullseye board. Okay, and you see that we have 4 shooters, A, B, C, and D. Now look at this person D. Okay, so what is your target here? Your target is to hit the bullseye, which is the red center, right? So you want to hit the center. That's what is your target. All right. So look at this person D. He is neither precise nor accurate. Look at his points. They are not closer to each other. He's not repeating what he repeats. At the same time, he's not on the target. Right? He has only twice he has hit the target. So he is neither precise nor accurate. Look at B. Look at B. So B, when you look at, he is very precise. He has repeated what he has been doing. He's shooting the same point again and again. He's exact. This is called as exactness. Exactness in the sense exactly hitting the same point. not necessarily the target. Okay, so he is hitting the point again and again, the same point. He is precise but not accurate. So number B, the person B, accuracy wise low accuracy, but precision wise high precision. Look at C. Look at C. This person, he is closer to the target. He is closer to the target, but he is not precise. When compared to B, he is not precise at all. So there is a huge distance you can see from every point that he shot. So this guy, accuracy wise, yes, he is accurate, but low precision. Low precision. He is valid, but not reliable. He is valid, like, three times, and near valid multiple times, but not reliable. Whereas B, he is reliable. You know next time where he will hit, but he is not valid. Because what is validity? Hitting the bullseye. That's validity. Now we have A, who is both accurate and precise. He hit the target and consistently hit the target. So he is both accurate and precise, high validity and high reliability. So precision and accuracy both have to be reached if you want to make your process a Six Sigma process. You got to be consistently achieving high results. That's the goal of Six Sigma. But the very first thing that you have to achieve is B, precision. If your process is like D, first you have to move to B, then you have to move to A. First you have to reduce your variation, then you have to move your target, right? So if you are working like B, then you will move to A. Depending upon what is your present condition, your target will be different. You understand? So from B you can move to A, or from C you can move to A directly. But if you're working, if your process is like D, it is neither on target nor precise nor consistent, no uniformity. You see a lot of variations. Then first of all reduce your variation, then you go for accurate results, right? I hope that you would have understood the difference between precision and accuracy. Of course you can put your questions in the chat box. Right? So when you say a particular process is precise, it not necessarily be accurate. When you say precise, you exactly mean that you're consistent, you're uniform, your results are uniform, not necessarily to the target, and vice versa. Precise does not mean accuracy, accuracy does not mean precise. You have to measure the precision and also the accuracy and try to improve both. That's the goal of Six Sigma. So when it comes to improvement, there is a mantra: sustain what you improve and improve what you sustain. It is not only important to improve, but you have to sustain. So when you move from one step to another step, you have to standardize. Only after standardization, you will think about the next step. Some organizations you would have seen, they continuously talk about improvement, but never they talk about standardization. But some organizations are too much adhering to the standard. They have a lot of problem in breaking the status quo. You have to have an open mind to change. Change is for good. Change is for improvement. At the same time, whenever you change, whenever you put a desirable change, you have to standardize. So improvement is nothing but moving towards the target, accuracy, trying to fine-tune your accuracy. That's what you call as improvement. Whereas standardization is trying to achieve precision at that level. Move, sustain, move, sustain. Break the status quo, improve, and once you have improved, form a status quo. Status quo is a present stable state. People should be comfortable with the newer change. That's called a status quo. People should completely forget the old procedures. They should completely adhering consistently to your new procedure. And then only you have to think about the next improvement. If not, people will, if you don't have this standards, if you don't have the standard set, then you will roll back very quickly. You will roll back to the level 0. So move to level 1, standardize, move to level 2, standardize. Then even if you move down, only one step below you will move down, because that is, you have done a standardization. That is the real improvement. Accuracy, precision, accuracy, precision. That's how you gotta improve. So Six Sigma is basically to measure your precision of your process and accuracy of your process, and understanding what is your process, how is your process, and implementing a lot of tools, a combination of logical and statistical tools to understand the cause of your low accuracy or low precision, and changing the procedure, changing the process, procedure, men, everything. Men in the sense, I mean the training, providing training to the men. Okay, so implement all mantra, yantra, tantra to move ahead towards the next step. So Six Sigma is a data-driven approach. You measure the data, you measure your precision and accuracy, and then you will identify the process status, and then you will move ahead. Once you have moved ahead, again you will measure the precision and accuracy, and then you will standardize continuously, right? So Six Sigma, sigma means what? Standard deviation. Deviation means what? Variation. Standard deviation is a measure of variation. So standard deviation, if you are measuring the process, always, we are all the time, we are interested in average, right? When somebody says my productivity is 100 units today, 200 units today, next day 300 units another day, 50 units another day, immediately what we ask, the usual question that we ask is, what is your average production? We are all the time interested in average, but very, very rarely we think about the deviation, standard deviation. Average have no sense if you don't measure the standard deviation. Average and deviation, standard deviation, both the measures should be seen together. It's not only the average that you will look at, you will look at what is their variation. So one day somebody have produced 50 units, another day somebody have produced 100 units, again 200 units, again 10 units. There's a huge variation. Your average is not a true average. So that's the first enlightenment that we have to have. So don't measure only average, measure the standard deviation, which is denoted by the Greek letter sigma. So identify the standard deviation and try to reduce your standard deviation. That is your variation. So Six Sigma is to reduce variation. So statistically, let's say you have a process. Once you have taken the process measures, let's say you get an orange curve, the curve which is in orange. So this orange curve, and you can see the middle line, the middle line is the mean line, the average line. Okay. So now you look at the orange curve, the spread of the curve is very huge, right? So you see a very huge spread, right? You see a very huge spread here, correct? So, which means there is a huge deviation. For the orange curve, if you measure the standard deviation, you will get a huge standard deviation. During our regular sessions, during our usual sessions, we will discuss how to calculate standard deviation. That and all we will take care. Of course, you would have studied standard deviation during your school days, but most of the time when we were in school days, we would have usually studied without knowing the application knowledge, correct? So we will discuss like how to calculate the standard deviation, what exactly it means when it comes to a process. So usually when you calculate a standard deviation for the process that is graphically shown using the orange curve, it would be very high. So what you wanted to do? You want to convert your orange process into a blue process. So the blue curve, if you see, the variation or the spread is less. The average for both the processes could be the same. Before improvement, you would have got the same average, and after improvement also you would have got the same average. You see, even if the average is same, there is a very great possibility that your standard deviation is different. We always give importance to average, but we forget or we will not have any awareness about standard deviation. So that is the first area that Six Sigma training or Six Sigma methodology trying to tell you. Please measure your spread, measure your dispersion. If your dispersion is very high, then you are not predictable. There is a very great possibility you will produce more failures. All right. So trying to reduce the variation, that's the major point when it comes to Six Sigma. So you don't want to have too much variation. You wanted to reduce variation more and more and more. So immediately you cannot go for Six Sigma quality. If your process is at only 1 sigma level, then you will go for 2 sigma level, 3 sigma level. So you can improve step by step. Immediately you need not to jump to a 6 sigma level. You may move from 2 sigma, 3 sigma, 4. First of all, you have to know what is your sigma performance. Correct? So now let me give you a view about what is Six Sigma, what exactly is meant by Six Sigma. So I'm going to use a whiteboard to explain what is this 1 sigma, 2 sigma means. For example, let us say that you are into a pizza delivery business. Okay. So in your pizza delivery business, you understand that your customer do not want a delivery later than 30 minutes. So what is the specification for your customer? The specification is 30 minutes. He don't want any kind of a delivery beyond 30 minutes. Okay. Now, you want to know whether your process is capable, enough to go ahead and produce this result. For which, what would you do? You will first measure your process. Let's say for the last 100 pizzas that you have delivered, you will measure the delivery time. Okay, for the last 100 pizzas, for example. Now you have got some data. Let's say one of the process you have delivered it in 29 minutes. Another pizza you have delivered it in 35 minutes, 40 minutes, 30 minutes, 20 minutes, 45 minutes, 50 minutes, 30 minutes, so on and so forth. So for 100 data you have. From this data, you can calculate something called as average, which I call it mu. Okay, let's say your average is 30 minutes. Finally, you got your average is 30 minutes. Okay, because you have extreme low values also, extreme high values also, that's okay. But you got this as your number. All right, this is your average. So just when you look at the average, you think that, okay, your process is capable. Because average is 30 minutes and your specification is 30 minutes, you think your process is capable. No, no, no. You have to calculate something called a standard deviation, which is denoted by a Greek letter sigma. So there is a formula to calculate sigma. And after you calculate the sigma, let's say you understand that your deviation is, your average deviation is 10 minutes. Your average deviation is 10 minutes. Okay. So now your mu is 30 minutes and your specification limit, which I'll denote it in a blue line. So the blue line, okay, your specification is also 30 minutes. So this is the red color one is your mu or the average, and specification is, I call it specification limit. The specification limit is 30 minutes. Now between mu and specification limit, how many sigmas you are able to fit? You are able to fit is 0 sigma, correct? Because it is the same. So there is nothing you can fit. You understand? But if at all, your average instead of 30 minutes, if at all, if it is 20 minutes, if at all it is 20 minutes, now how many sigmas you can fit? So now your mu is the same. Now, sorry, your mu is 20 minutes. Your specification limit is the same. Okay, 30 minutes. Customer is not changing his requirement. Okay, so your average have become 20 minutes. Now, how many sigmas can you fit between mu and specification limit? Put your answers in the chat box. How many sigmas can you fit between mu and specification limit? Mr. Ahmed, it is not 10 sigmas because 1 sigma is 10 minutes. 1 sigma is 10 minutes. So how many sigmas? 1 sigma, correct? Yes. Because 1 sigma is 10 minutes. So 20 plus 10, 30, correct? Do you get that? So now, if at all you are reducing your deviation, your deviation is reduced from 10 minutes to 5 minutes. Now how many sigmas can you fit? How many sigmas can you fit? 2 sigmas, correct? So your process accuracy should go to an extent of 6 times of sigma. In the sense, you should be able to fit 6 sigmas between your mu and specification limit. That is what you call a 6 sigma quality. So where can you reduce? You have to work on your average, you have to work on your standard deviation, right? So in both the ways, if you work, or at least first to start with sigma, then you can work on average, because reducing average is very difficult, right? Because reducing average means you have to put a lot of investment to reduce the average, but at least first to reduce the deviation. So now if the sigma is 5 minutes, you are able to fit only 2 sigma, right? So if it is 2.5, you can fit how many sigmas? If it is if your sigma is 2.5, how many sigmas can you fit? 4 sigmas, correct? I want to fit 6 sigmas. If I want to fit 6 sigmas, then how much should be my sigma? How much should be my sigma if I have to fit 6 times of sigma? If my present sigma is 2.5, if my present is 2.5, then I can fit how many sigmas? 4, right? Because 2.5 into 4 is equal to 10. Correct. Now I want to know how much I have to reduce in order to fit 6 sigmas. 1.66, correct? 1.66. So if my sigma is reducing to 1.66, then I can fit how many sigmas? 6 sigmas, correct? So earlier your deviation was 10 minutes. The average deviation was how much? 10 minutes. Now you're reducing the deviation to how much? 1.66. For which what you require? You have to standardize your process. You have to produce consistent results. Of course, we will see what is the problem, why there is 10, why there is a huge deviation. That we have to use multiple tools to understand the problem, why there is a huge deviation. I'm only talking about a target side. I'm not talking about the work site. Do you get that? So this is what you exactly mean by sigma. Okay, reducing, this is what you will get when you are reducing the deviation. You understand? Do you understand what is the meaning for Six Sigma? Six Sigma is when you say your process is capability. When you say your when your process capability is Six Sigma capability, which means you're able to fit 6 times of sigma between your average and your specification limit. So I have got a question. What is the difference between specification limit and control limit? Actually, control limit is a process limit, which is derived from your process. Okay. Whereas specification limit is the target given by the customer. So customer limit is called a specification limit, and your control limit is your process limit. People who do not know what is control limit, it's okay. It's completely okay. So usually control limit is kept at 3 sigma. Okay, your control limit is 3 sigma. This is the limit that you keep for yourself. This is to understand the control of your process, whether your process is stable or not. Okay, but this does not talk about your capability. Control limit will only talk about whether how is your process behavior. It will not talk about your capability. Okay, so control limit is process limit. Control limit is the voice of your process, whereas specification limit is your voice of your customer. All right. So it would take me few more minutes to tell me what is the difference between control and specification limit. We can take it later. So let me move on. Okay. All right. So okay, so there is a question that says, are there certain rules to be followed or written principle which we need to follow for control limits, control and specification limits? Yes, you have to. Okay, so there are many rules. So in a raw way, if I say control limits are at 3 sigma, but there are specific calculations. There are, depending upon your type of data, the rules will differ. Okay, so there are different types of control charts: X bar chart, R chart, C chart, U chart. There are different types of control chart. So depending upon the control chart type, okay, depending upon the control chart type, how do you choose the control chart? It depends upon the data in hand. Okay, so depending upon the data, the control chart type and the respective control limit formula, everything will change. Okay, so just to give you an overview, what is control limit? You are trying to identify your process boundary. What is your performance? You're trying to identify your boundary of performance. That's what you call as control limit. That is for yourself. That is derived from your own process. Whereas customer doesn't care about your process limit. He gives his target, right? So the specification limit is given by the customer or by the end user or whoever is going to get the delivery. Okay, so that man or woman is going to give you the specification limit irrespective of your control limits. Specification limit is given to you irrespective. He doesn't care about what is your process performance, what is your boundary, what is your range, standard deviation, nothing he cares. He gives what he wants, right? So that's what you call a specification limit. There's a very huge misconception about specification limit and control limit. People think that specification limit is based on control limit. No. Okay, specification limit or control limit are independent of each other. Okay, but if at all you have control limit, if at all by God's grace, I should not say, because definitely quality is not by God's grace. Quality is an effort that you take. Okay, so let's say without even any effort. But by God's grace or by luckily, if you have got your control limits within your specification limits, okay, fine. Okay, you're lucky, or your customer is very generous, but they do not have any dependency. Control limit and specification limit, they have no dependency. All right. So it's a concept that requires another few minutes to explain. Okay, so I'm not getting into it. Maybe after the final this one, maybe I'll give you a little more light on it. Okay, after we complete it. Okay, fine. So the point here is, in order to, if at all you make your process Six Sigma capable, in the sense you are reducing your variation to such an extent such that you can fit Six Sigma between your mean and your customer specification, then what is your yield? Then the yield is 99.9997% yield. Okay, look at this figure, 99.9997% yield. Okay, so if your sigma level is 6, so what is your yield? 99.9997% yield, which means if you produce 100, if you are giving an input of 100 units, there is a guarantee that 99.9997% good yield you will get as an output. Okay, this is statistically derived. This is statistically derived. The statistical basis is probability distribution, which is normal distribution. Okay, so as per the normal distribution theory and statistical tests, so this number is derived. Okay, so that is why, so when you're capable of producing Six Sigma capable processes, then you're producing a great yield. So if you have to convert into a defects, okay, so Six Sigma means 3 defects per million opportunities. How much? You're producing only 3 defects per million opportunities. Okay, 3 defects per million opportunities. So this is the, so in order to tell you because people always wants to see how many defects, right? They want to see the numbers instead of seeing the percentage. For that reason, it is converted. It is converted for people who are interested in this defects per million, etc. Okay, so three defects, actually precisely if I have to say 3.41 defects per million opportunities. All right, so there is a difference between defect and defective. Okay, and defect means variation. Any variation is called as defect, whereas defective is rejection. For example, your average process time is 30 minutes. Okay, so the next delivery, when you see, you are delivering it in 35 minutes. Now the difference here is 5 minutes, right? Your average is 30 minutes, and your next time you deliver, how much you are delivering, at what time you are delivering? 35 minutes. So what is the variation here? 5 minutes. So a variation is called as defect. Again, there is a misconception. This is what we have to understand when we are getting into the Six Sigma training. What is the difference between defect and defective? People generally use the word defect and defective. In a layman term, we mean the same. Okay, but generally a defect is any deviation from the target. Okay, so any deviation from your number that you keep in mind, that you have in mind, right? So if you have more and more variations, you are going to see a lot of rejections. So in an iceberg, variation is under the bottom of your process. It is not immediately seen. You will immediately notice only the rejections. When a customer rejects, when the customer complains, that's what immediately we jump into. But if your process have reached to a level of customer complaints, which means already there are a lot of variations happening. Overnight, your process is not producing any defectives. Overnight, the customer is, your process have not suddenly become incapable of meeting the customer needs. So for a long time, there have been a variation which you have not taken care of, which you have not measured, which you did not take care of. And that's why over a period of time, it has grown to such an extent, now the problems are visible. You understand? So where we have to work on, we should not firefight. Correct. So the moment you see a defective, the moment you see a customer rejection, immediately we jump into the field and we try to satisfy our customer, right? But where we have to really work on, of course, you have to immediately take an action. That's a different story. But after you take an immediate action, immediate containment action, you have to come back and look into your processes, depth of your processes, and reduce the variation such that you seal it forever. You prevent it forever, right? So come back and look at your variations and reduce the variations. So Six Sigma study starts right from the bottom of your iceberg. All right, so it reduces the variation. If you got to implement Six Sigma, so so far we talked about what Six Sigma means, what is the target of Six Sigma, what is the yield that it provides. Now we will talk about how do you move on, what would you do to implement Six Sigma. I hope most of you would know about what is PDCA, right? PDCA, what does PDCA means? PDCA cycle or PDCA simply? PDCA stands for Plan, Do, Check, Act, correct? Yes, Plan, Do, Check, Act, that's right. So from the Plan, Do, Check, Act only, the Six Sigma steps also came into picture. Here there are 5 steps to implement Six Sigma improvement. Define, measure, analyze, improve, and control, right? So this PDCA is called as Deming cycle, as Mr. Bhaskar have rightly put it. Yes, it's known as, some people call it Schwartz cycle, some people call it Deming cycle. So from the PDCA is the basis for most management models, not only Six Sigma, but also for many management models such as TQM, ISO, or even contract management, project management. For all management models, PDCA is the basis. So Six Sigma also follows the steps of PDCA, but a little bit fine tuning and adaptations done here. So define, measure, analyze, improve, and control. These are the steps. First, define the problem. Define the problem. Say the problem in quantitative means. Use techniques to identify the problem. That's step 1. Then numerically measure it. Numerically go for an in-depth measurement. You would have defined the problem as per your understanding. From your rejections, from your customer rejections, you would have defined the problem. Now you go to the depth of the process and measure the process metrics. Measure the cycle time, measure the lead time, measure DPMO, measure process capability, measure your sigma. Put them in graphical formats, histograms, Pareto charts, box plots. So use graphical charts to put your what do you call, measurements to visually see it. Then go for furthermore depth analysis. Analyze. Use advanced statistical studies such as hypothesis tests, multivariate charts, design of experiments. Go for a bit advanced tools to go for an in-depth analysis to really understand where exactly the problem lies. Go for correlation, regression. And then identify the real cause, identify the real factors which you have to improve, which you have a great say on your process. Identify those, then bring improvement. Use lean tools or use Improvement is straightforward. The most important thing is to identify the right factor and the right cause. If you have identified the right factor and right cause, improvement is straightforward. If you see the problem is with the procedure, change the procedure. If you see the problem is with the machine, change the equipment. If you see the problem is with the measurement device, change the measurement device or calibrate the measurement device. If you know where the problem is, then the solution is straightforward. Of course, you can use some of the lean tools, some of the common sense lean tools to bring improvement. After you bring improvement, consistently ensure that the people are following the new procedure. Control, sustain, right? So identify the issue, collect data, study the process and data for clues, act on the data for improvement, and sustain that improvement. So these are the steps. So we will be in the class, we will be talking about what are the define tools, what are the steps in define, what are the measure basic statistical measures, what are the basic visual tools, and in analyze we will talk about advanced statistical tools, and in improvement we will again talk about lean tools, and in control we will talk about control charts, how to sustain, how to identify whether your people are on your new process. All right, so this is what we will see in Six Sigma session. And now let me quickly give you an introduction about lean. A lean, originally called as Kaizen, Western people call it lean, and Southeast call it Kaizen. So this came from Toyota. The originator for lean is said to be Toyota. Again, thanks to World War II, Japan have gone to such a huge development. It is because of the pain and the damage that they encountered during World War II. So they were able to rise. They rose exponentially. So before World War II, before the Hiroshima-Nagasaki incident, so Japanese products were known for people who were in, who have born in 50s. Okay, so they would have known this. So during 50s, okay, but because after 50s there is a great change. Okay, so 50s or before 50s, Japanese products were known for it is considered like, how do we consider Chinese products today? That is the attitude towards Japanese products. So Chinese products, in the sense, we will usually say it is a cheap, use and throw, less cost. Okay, but today when you say Japanese make, any make, be it an automotive or a camera or any kind of a gadget, or even a very simple tool like shoes or a knife, any simple tool to a big gadgets or automotives. When you say Japanese product, people immediately attach the word quality with the Japanese product. So Japanese products means robust design. Japanese products means long life. Japanese products means great finish, right? I'm not talking about exceptions, I'm talking about most of them. So the main reason is the attitude change. So many Japanese organizations had an attitude change, particularly Toyota. So Toyota, what did they do? They reduced waste, eliminated waste in order to achieve a greater productivity and efficiency. So lean, definition wise, it means operational excellence strategy that enable people, organization to change for the better. So lean, although Toyota Taichi Ono, he's been given a credit for lean. Lean was originally called as TPS, Toyota Production System, which later got a generic name called as Kaizen or lean. But again, the pioneers for TPS is Frederick Taylor, who is known as father of scientific management, and Eli Whitney, who is known for producing standardized parts. So these are the pre-runners to TPS. So of course, Toyota have used these concepts to an utmost accuracy, to an utmost extent, such that they developed a concept called as TPS. So when it comes to Toyota production system, philosophically, there are actually two pillars. There are two diagrams of TPS. One is philosophical house, another one is tool wise, okay, technique wise. So philosophically, if you look at the two major pillars of TPS is continuous improvement and people empowerment. Respect for people and continuous improvement. If you look at Six Sigma, it gives more importance to the data. Whereas when you look at lean, it gives more importance to the common sense, the creativity. Creativity is putting your common sense in an uncommon way. Creativity is usage of common sense only, but in an uncommon way. So giving importance to the people's creativity and common sense, that is lean. So lean would not so much, of course, there is a little bit of data involved in TPS also, or in lean also, but to a greater extent, they see it, they visually see it, they experience it. Okay, instead of having a person who is statistically collecting the data, they will go to the process owners, they will go to the operators who are actually facing the problem. In lean, there is a terminology called as Gemba walk. Gemba means the real place where the productivity is happening. So for a trainer, the Gemba is classroom. For a manufacturing company, the Gemba is the shop floor. Right? So the Gemba is where the real process is happening. You have to go to the Gemba to understand the problem and bring improvement. So empowering people and improving continuously for sustainable development. So that's the philosophy of lean. So the word Kaizen came from a book written by Masaki Imai. Masaki Imai he coined the word called as Kaizen from his book. He studied the Toyota production system, and from the Toyota production system only he wrote this book. And there were another set of people, James Womack, who wrote a book by the name The Machine That Changed the World. In his book, he also studied the Toyota story, but he called that methodology as lean. Lean means flexible. When you say somebody is lean, which means they don't have unnecessary fat. So unnecessary fat is a waste. So if you want to be lean, you got to be, if you want to be flexible, you have to remove the fat, the unnecessary fat, cholesterol, right? So similarly, if you want your process to be lean, why you want your process to be lean? Because you want your process to be flexible. You want your process to be immediately changeable, workable, for which you have to eliminate the waste. All right. So the word lean is coined by James. So lean became popular in Western world. Some people try to differentiate the word Kaizen and lean, but I don't agree. Personally, that's my opinion. I directly got training from Kaizen Institute, India, which is a direct unit of Kaizen Institute, Japan. The Kaizen Institute is run by or founded by Masaki Imai. So from the person who, from the institute who actually have the person who have coined the term Kaizen. So as I have gone through the training, and I've also gone through the IASSC standards where they discuss about lean. So I personally, after studying these two side of stories, according to me, I don't see any difference. So it's just a marketing, okay? So Kaizen and lean are fundamentally the same. The word, the lean or Kaizen, talks about waste elimination. So what do you mean by waste elimination? First of all, what is meant by waste? Any activity that is non-value added is called as waste. Any activity that does not produce any value to your customer is called as waste. For example, your customer is buying a product for the conversion. You converted the raw material into a output. For that conversion he is paying. He is not willing to pay for the damage that you have created, the rework that you have made, the transportation that you are working on, right? He is not willing to pay for all those things. He is not willing to pay for your breakdowns. Of course, they are adding this into the price. But if at all you tell your customer that, dear customer, the raw material cost is 2 dirhams or 2 riyals, and the conversion cost is 3 riyals. So totally for conversion and raw material, the cost is 5 riyals. But the cost of the product is 50 riyals because I had a breakdown, I had to transport, I had rejections, I had a changeover time, I had idle resources. For all this, and my profit margin. So for all this, I got 50 riyals as the price. Now he would say, okay, I'm ready to pay your profit margin, but why should I pay for your inefficiency? Breakdown time, unnecessary idle resources that are your inefficiency. He's not willing to pay for your inefficiency, correct? Even we don't want to. Why inefficiency is neither helping your customer nor you. It is not added on to your bank reserves, nor to your customer, not saving money from your customer pocket. It is harmful for both of you, correct? So we would try to reduce the waste such that we will concentrate on only value. We will only produce value added activities. We'll only focus, or we will only add value, and we will eliminate non-value added activities. So who determines value? The customer determines value. What is valuable, what is not valuable, what is value added, what is not value added? Who will determine? Your customer. For whatever activity, for whatever feature your customer is willing to pay for, that is called as value. Whatever your customer is not willing to pay for is called as non-value added. For example, you are all here for every sensible word that I speak, right? So if I'm taking time on speaking some sensible word around the topic, you're willing to pay your time. Here there's no money involved, but here you're investing your time. But if at all I'm taking time for fixing my laptop, fixing my PowerPoints, navigating the windows, you will get frustrated. If we have too much of technical glitches, you will be frustrated, right? You're not willing to invest the time on those non-value added activities. You want me to be ready, and you want me to produce the value which you consider as value, correct? So that is what we have to do in our process also. We would, of course, reducing non-value added activity to 0 may not be possible, but you will strive to reduce as much as you could. So what do you mean by non-value added activities? The waiting time, breakdown time, inventory, over processing, setup, inspection, changeover, all of these are non-value added time. Sometimes we segregate some of them as necessary non-value added, So setup time, we have to set up the machine. So it is required. So it is necessary non-value added. We do conduct inspections. Inspection is necessary non-value added. So, but waiting, it is completely non-value added. Breakdown, it is completely non-value added. Inventory, people may not agree with me now, but maybe during the session after we explain, somebody was talking about JIT, right? Just in time. Just in time is to reduce the inventory. Yes. So actually, in fact, necessary, there is nothing called as necessary non-value added activity. Nowadays, Japanese machines are coming up with a design that could even eliminate the setup. You don't even, it's kind of a plug and play. You don't require any time for setup. So you can even work on reducing this necessary non-value-added activity. This is just for satisfaction for some of the people. Nowadays, they are calling some of the non-value-added activities as necessary non-value-added activities. But the lesson that I got from Kaizen Institute was not, there's nothing called as necessary non-value-added activity. You have to eliminate it. You have to strive more and more by improving your process, by improving your product, by improving the design of your machines, tools, equipments, to reduce the non-value-added activity. The time when you start telling that some non-value-added activity is necessary, then your attitude will become, okay, this is necessary, so all right, let me go on to some other non-value-added activity. No, there's nothing called as necessary non-value-added activity. But nowadays in certain books, including the IASSC books, they are segregating it as non-value necessary and not necessary non-value-added activities, right? But even if you have necessary non-value-added activities, yet you have to try to reduce that non-value-added activity. So these non-value-added activities are generally called as muda. Muda means waste. Elimination of muda. There's a question which says, what is WIP? WIP means work in progress. Work in progress means you have something waiting on the queue. You have something waiting on the queue. When you have bottlenecks, you will have queue, right? A queue, waiting in a queue, a person waiting in the queue, or a product waiting in the queue for the next process to process it is WIP. Okay, work in progress. Thank you, Mohammed, for your explanation. So muda means waste. Muda is a Japanese term for waste, a Japanese term for non-value added activity. Okay. So muda, there are 8 types of muda that Kaizen is talking about. I will just list them. Overproduction is a muda. Waiting is a muda. Transportation is a muda. Overprocessing, inventory, movement or motion, producing defects, all of them are muda. Overproducing, producing more than required. In fact, overproduction is called as mother of all mudas. If you don't understand your customer demand, or if you're not really working on the demand, then you cannot exactly, you will produce all the other mudas. All right. So these are called as mudas. So eliminating these mudas. And lean involves usage of visual tools. So in Six Sigma, you are using statistical tools. In lean, you use visual tools. Everything visual. Using color codes, using signals, using indicators. So make problems visible. So technique-wise, the 2 important pillars of lean is JIT and JIDOKA. JIT means just in time. Just in time means not overproducing, reducing the inventory. JIDOKA means using machine and men together, automation. Okay, not automation. Automation is different from automation. Automation is complete usage of machines and robots. Whereas automation is the right level of synchronization between men and machine, because men's creativity is very important to improve the process. So that's what we say, respect for people. Okay, respect for people. On one hand, you work on making your process smooth, free of defects or free of inventory and overproduction. So these are the two pillars when it comes to lean. So if people are debating about lean or Six Sigma, which is better? No, you have to integrate lean and Six Sigma. On one side, you have to eliminate the waste. On another side, you have to improve the stability and reliability and validity. You have to reduce your variation on one hand, and you have to remove waste on another hand. So usually you will start with lean. First do the lean. So once you, because lean does not require any great investment. Lean is otherwise called as zero investment improvement, ZII, zero investment improvement. So lean requires only logical, common sense approach. So first to do a lean, such that you will eliminate as much as waste as much you possible. Then go ahead with the Six Sigma. So use it together. Eliminate waste and eliminate variation. Together, it would improve the processes. So lean eliminate waste, and it will ensure that you have a smooth process flow, no bottlenecks. It will ensure that you are producing based on a pull approach, in the sense you are not overproducing, you are producing for the demand. You are not pushing, you are pulling. I mean, your customer is pulling. You are producing for the customer's demand, and use visual tools to do this. Whereas on another hand, Six Sigma will look on variation reduction. It will concentrate on process yield, 99.9996% of yield, making your process capable, and uses a statistical and analytical approach. So both are required ultimately to produce a quality output such that customer satisfaction. So both have to be integrated. All right. So that's about lean and Six Sigma. To give you quickly what are the different belts available for Six Sigma, these are levels: yellow belt, green belt, black belt, and master black belt. So these are the levels. So in the present Six Sigma, although the name of the green belt, I mean the name of the training is Six Sigma Green Belt, in fact we will discuss basics of lean. Okay, we will give what is lean, what are the 8 types of waste, what does every single waste mean, what are the lean tools, what is JIT, what is Judoka, there are so many lean tools such as 5S, you would have heard about it, 5S, and on Kanban, all the Japanese names. All right, so we will talk about all these tools and the usage of these tools, example of these tools. So at a basic level, we will cover lean also. And then we will go for a deeper Six Sigma study. So there are belts like yellow belt. Yellow belt is the level 1. And then we have green belt. So yellow belt, they will only have a foundational knowledge. They are very new to the world of Six Sigma. They cannot be a leader of any Six Sigma project. They can participate as a team member for Six Sigma project. Whereas green belt, if somebody have attained green belt level of knowledge, then they can work as a member in black belt projects, and they can lead green belt projects. So what is green belt project? What is black belt project? So if a process improvement is happening at an enterprise wide, so if there are multiple departments involved, multiple departments required to be required to be come together to improve a particular process, then you call it a black belt project. A black belt is usually an organization wide improvement. It requires interfaces of multiple divisions, whereas green belt project is a local improvement within a department or a process of a department. So that's a green belt project. So sometimes green belt and black belt is based on the budget. So in several organizations, they will say that, if a project is worth around $1 million, it may not be $1 million also. Okay, it can be $100,000 depending upon your organization's value. So if it is a high budget, they call it black belt. If it is a low budget, they call it green belt, according to your turnover and value. Okay. So likewise, they differentiate between black belt and green belt. So a green belt certified person can handle green belt projects, a local, a department level, or within a process level improvement. But if you want to go for an enterprise-wide improvement, if you want to handle an enterprise-wide improvement, then you gotta be a black belt. You should know some advanced concept in statistics. When you are doing a green belt, you will know all basic statistics and all logical tools, but advanced statistics will not be covered in green belt. Whereas in black belt, all the thorough understanding of DMIC and advanced statistical concepts will be covered in black belt. A master black belt is someone who can even coach black belt, and he is very close to the CEOs and strategic people who are in strategic departments. So they will identify the black belt and green belt projects. So if you have a perfectly good or perfectly a perfect Six Sigma organization, then they will have black belts, master black belts, and green belt. You can see a good structure of black belt, master black belts, and green belts. Or if you're individually interested, you can start with, you need not to go for a yellow belt. Okay, you can straight away go for green belt. It is not, yellow belt is not a prerequisite for green belt, but for black belt, green belt is a prerequisite. If you want to become a black belt, at least you should have handled 2 green belt projects. Then only you will become eligible to go for a black belt. I'm talking about IASSC examination. Okay, you got to be a green belt certified, and you should have got experience in green belt projects, and then only you can go for black belt. But for green belt, yellow belt is not a prerequisite. You can straight away go for green belt. And if you're in the green belt, we'll start from the scratch. So there is no need of any pre conditioning or a pre knowledge required. Okay, so IASSC, American Society of Quality, is a US based certification, and this certification is one of the globally recognized. There are many bodies, but IASSC is one of the popular one, and it is globally recognized. So so generally we train. You can even if you do a green belt course with Al-Kamal, you can even take an IASSC exam, or you can even take a IASSC exam. But we generally recommend IASSC exam because it's pretty easy. Easy in the sense, pretty easy to schedule the examination. You don't have to wait, because IASSC is only done by authorized centers. So IASSC, you can get your seats very easily, and it is much more popular than IASSC. So IASSC, if you want to go for a IASSC examination, it is a 1 green belt examination. The examination is a 4.5 hours examination that consists of 110 questions. All of them are multiple choice questions. So you should have at least 3 years of work experience to go for a green belt examination. 3 years of work experience. Not they don't say as a quality manager or engineer or nothing. Simply you have 3 years of experience in any field, in any designation, you can go. You are eligible to go for a green belt certification. The examination fee is $438 for non-members, and $338 for members. Anyway, for members, if you want to become a member, you have to pay nearly $150. So you can straight away go for $438. This is your examination fee. If someone fails, they have to go for a retake. It is $159. But of course, green belt is relatively a simple examination. So as long as you do a good study, a basic study, you would never fail in a green belt examination. None of my students have ever failed in a green belt examination. All right. So this is the brief about Six Sigma and Lean. Hope you have got. I'm ready to take your questions. I understand that I've taken more time. Okay. So I've started getting questions. Will course material be provided, or it is a GK based learning? No, a course material will be provided. IASSC's recommended guide will be provided, and I will be providing you the teaching notes as well. And the calculations, everything will be done. Okay, it is based on a body of knowledge. So that is the IASSC's body of knowledge. So the guide is based on the body of knowledge. So you will receive those books. You will receive the books, you will receive the practice questions, everything. I'm in logistics, so which path is right for me? Logistics, what do you mean by which path? Are you people thinking that Lean and Six Sigma are two different paths? No, it is an integrated path. All right. So Six Sigma, when you are studying Six Sigma Green Belt, of course, you will be studying a Lean also. So this is the first level. Okay, so first level is knowing the basics of Lean and Six Sigma through the Green Belt. All right. How this can be useful specifically in construction industry. Okay, one thing that I agree is construction industry is little behind when it comes to quality improvement models. When it comes to manufacturing or IT, even though IT is a project-based industry, construction is also a project-based industry, IT is also a project-based industry. But when compared to IT or any other project-based industry, the importance for quality improvement model in construction industry is relatively seen low. Okay, but it is booming. It is. So nowadays you can see agile project management, agile project management, or lean project management is an offshoot of Lean and Six Sigma. It is an offshoot of Lean and Six Sigma. So whatever, so Lean project management is becoming popular in construction industry. So when you have a basic understanding of Lean and Six Sigma, this would help you in future. But as of now, the application in the industry as a whole, particularly in Middle East, it is pretty low. All right. In all kind of operations, all our, be it operation or be it a project, all our operations and projects are composed of processes. Correct, it is all composed of processes. So you want to improve your processes, you want to improve the efficiency of your processes, you want to reduce the duration or time taken of the process, or you want to reduce the defect of your process, or you want to there are metrics, there are different metrics. When it comes to manufacturing industry, it is defects. When it comes to service industry, you call it errors. Correct. So all your processes have to be improved, right? Irrespective of the industry you come from, you have to study the process and you got to improve your processes. Correct. So whether it is a project environment or an operation environment, whether it is a product based industry or a service based industry, in all the cases, process improvement is common. Process improvement is common for any kind of industry or any kind of environment. Correct. So process study, understanding process metrics, using problem solving tools is common for any industry. All right. What is the percentage required for pass? The pass percentage is not explicitly given, but it is around 65 to 70 percentage. 65 to 70 percentage to pass. So you have to aim for at least 75 percentage. Okay. All right. So regarding your course related detail, regarding your start time and stuff like that, Ms. Monisha is here to answer. Okay, I'll hand over the session to Monisha. Meanwhile, if at all you have any other questions conceptually or examination wise, I will be answering. Okay. So the course duration is 35 hours. The course duration is 35 hours. So usually you can see many institutes are finishing green belt in 16 hours, in 20 hours. So that's the maximum that many institutes are giving for green belt. But I don't agree, because that would not give you any good sense about green belt. So I will take, we have decided to provide the course for 35 hours. Okay. There is no grading system. There is no grading system because the pass percentage is nearly 70, right? So the moment you get 70, or a first class already. The moment you get your green belt, you're already a first class. So there is no grading system. It's either a pass or a fail. All right. So let me hand over the session to Monisha to answer your questions regarding the course dates and stuff. Thank you very much. It's been a glad meeting you all.
Thanks, Ms. Durga, for the wonderful session. Hope everyone enjoyed it. And we are planning to start a batch of Six Sigma from 28th of this month. And it's a live instructor-led online training. So it will be on Monday, Wednesday, and Saturday from 7 till 10 p.m. And we'll be sending a email about the course to everyone who have attended today's session. Those who are interested, they can just get back to us.
Thank you, Monisha. So your sessions, I mean, you will be receiving a detailed mail, and you will also get a link of today's session as a video link. So you can, if you want to go through the presentations, you can very well go through the presentations through the link that we provide you. And you will also be receiving a mail that details the course timings and stuff. I hope all of you have given your email IDs during the registrations.
I have mentioned the WhatsApp number also of mine as well as my colleagues Mani's. So just you can text your email ID if anybody has not provided. We'll be sending you a detailed email approximately by tomorrow. So if you have any queries, anytime you can just text us or call us in this number I've mentioned in the chat box.